Exploring 2.4, exploring frictional forces. Okay, what is a frictional force? A force between the contact of the two surfaces. Imagine you have a box on a surface, you apply you push it, right? Push it hard, but it's not moving because this is very heavy. When you try to make it start move, you have to apply a very high force. Why? Because here is the box and here is the process of the box when it contacts to the surface of the ground. And the ground has its own process, right? These two processes are locked in each other. That's why you need to apply a very high force to make them get out of each other. When it starts moving, these processes will be on top of each other, something like that. Slide on each other, so they are not locked anywhere. So they slide on the top of each other, they're not locked, and it means when the object is not moving, you have to apply very high force, and when it starts moving, you need to apply less force to make it keep moving. That's why we have a kinetic friction and we have a static friction. Here in this case, we have a static friction. In this case, we have a kinetic friction. Kinetic friction is much more smaller than static friction. Look at this diagram here. So here, the force of apply increase. The force of apply increase, and as the result, the friction force is increasing, right? As this is your box. This is F of apply. And it's not moving, right? It is experience statistic force. True. Is not moving means the velocity and exertion is zero. F of apply need to cancel statistic friction. So you increase your forces, of course, because they are the same when it's not moving. Therefore, as the F of apply increasing, the force of friction is increasing until at the maximum F of apply, you apply a maximum F to overcome the maximum static friction. At that point, when the object is moving, now the friction will decrease because your friction becomes kinetic friction. You have to apply less force to make it keep moving. That's why from here you jump down. So this is about that. So from here to here, you have static friction. And after that, when you increase the apply force, your object is moving. So you have a kinetic friction, which is much more smaller. Okay, let's just see if we have an example. Oh, and we have a coefficient of the static friction and coefficient of the kinetic friction. You know, force of the static friction, F of F static is equal to mu static multiplied by F of n, normal force. Mu is the coefficient of the friction. It depends on the physical properties of the surface contacts. Also, force of kinetic friction is equal to mu k, coefficient of the kinetic friction, multiplied by force of normal. So here is mu k depends on the property of the surface, physical property of the surfaces. As you see in this table, on a different type of surfaces, we have different static friction and kinetic friction. You see, all of this static friction compared to kinetic is much more bigger, right? Because of those reasons I explained it later, earlier. So always a static friction is bigger than kinetic friction. I'm gonna erase this. Okay. Okay, let's just do an example. A crate of fish mass 18 kilogram rests on the floor. The coefficient of the friction between the crate and the floor, static friction, coefficient of the static friction, and kinetic friction is given. The local value of gravitational acceleration is 2. Very significant figure. So G is 9.8. What is the force of friction and the acceleration? If the horizontal force is 75. Okay, if f of apply is, so this is the picture. We have f of apply, right? Since we have normal force and we have a gravitational force and we have force of friction. Okay, first thing I do is find out what is the maximum force of friction. So you know force of friction, maximum of that statistic force of friction, you need to overcome that, right? In order to move your object. Is mu k, mu s multiplied by f of n. Knowing f of n should be equal to f of gravity, they need to cancel because your object is not moving up and down. These two forces need to cancel each other. It's like total force in y direction should be 0. Therefore, f of n positive, mg is negative, so f of n is equal to mg. It's 18 kilogram multiplied by g, which is 9.8. It gives you 176 Newton. So mu s is 0.45. Multiplied by f of n. F of n is 176. This gives you 79.4. So this is maximum friction statistic. As you see, we are applying 75, which is really less than this maximum friction. You cannot overcome that force. That's why applying 75 Newton will not make your object move, right? Now let's just do if we apply 95. Of course, 95 is more than 79. So with 95 force, it will make your object move. You want to find we want to look for the acceleration. So again, we have the same system now. Applying 95 means my system is moving and it's kinetic friction now. So this part was A. I'm doing B. Kinetic friction is moving. 95 will make it move. So in X direction, you have f of apply minus f of friction kinetic is equal to ma. F of friction kinetic is mu k multiplied by f of n. F of n still will be the same. Mu k is 0.41. 41 multiplied by 176 equal to a number, and mass is given. F of apply I know is 95. Let me just go down to see what is the calculation for force of friction. It's 72.3. 72.3. See here is equal to 72.3, and the mass of the object is 18 kilogram. You guys need to just rearrange for A. You rearrange for A, just minus these two, divide by 18. A is equal to 1.26. 1.26 meters second square. This is the acceleration of the object. Now another question, you have a book. In a lab, a practical test, students are asked to determine the coefficient of static friction between the back of their calculator and okay, so what they do if they want to find the static friction between the book and the calculator, they put the calculator on the surface of the book and increase the angle slowly. At a specific angle, the calculator will slide down. And the student will pick an angle that if they increase it by a little, it will slide down. So they will measure the maximum angle that it can hold the calculator. Then they theoretically, having that angle, we can find the maximum, we can find the static friction. So this is the forces that you have on the inclined surface. Let me just make it better. Okay, so this is the textbook. The surface is your textbook. And this is the surface of the ground. This is the angle, maximum angle that you can hold the calculator. So this is let's say the calculator. So we have a gravitational force downward. So this is my F of G. Also, we have force of normal perpendicular the surface of the textbook. We have F of friction. F of friction is against the movement. So it's F of friction is static because it's not moving, right? As you know, I'm taking my y-axis to be perpendicular to the surface. I take my x-axis to be horizontal to the surface. And as you see, f of g has two components, x and y. If this is theta, we prove that this is going to be theta as well. So I have f of g in x direction, so I just put it there. F of g in x direction. Since opposite is sine, it's going to be what? It's going to be f of g sine theta. And y component, because the y is adjacent, so it's going to be f of g in y direction is equal to f of g multiplied by cosine theta. And everyone know f of g is mg. Okay. Now in x direction and y direction, all the forces cancel because they are not moving in x and y directions, the stellar. So also first of the friction is equal to mu s multiplied by f of n. In y direction, all forces add up to 0. I have just f of n, which is positive, minus f of g cosine theta. And instead of f of g, just put mg cosine theta, g cosine theta. So it's two force canceling, so y is equal to 0. So f of n, I get my f of n is equal to m of g cosine theta. I'm doing the total force in x direction going to be 0 as well, right? What I have in x direction, I have the frictional force, which is in this case positive. I just messed up that I put mu as f of n, right? And make sure if I get my f of n, so I just put that mu as f of n minus f of g sine theta. Instead of the f of g, I put mg sine theta. Sine theta equal to 0. I can rearrange for mu s. So mu s equal to, so mg sine theta to the other side become positive. Also, I'm dividing that by f of n. Divide each term by f of n. Also, I know the f of n is given mg cosine theta. So it's mg sine theta divided by mg cosine theta. Mg and mg cancel, and you have sine over cosine is tan. So tan of the angle, the maximum angle, is going to be your coefficient of static friction. Make sure, how do I know the force of friction is upward? Because if you increase your angle a lot, so it's moved down, and you know always the friction going to be against the movement. That's why this is up. Of course, this is toward that, so means your x component is down here. Anyway, so this is how we do this question. And if you have a dimension, okay, how do we know the theta? Right, the theta is rise over run, right? You measure the height of the textbook here and the run. So when you measure these two, which is 12 centimeter and 25, so 12 over 25, will be your tan. So basically, tan is 12 over 25, and we'll use 0.48, the coefficient of static friction. Now there is another example, I think. No, this is the last one. Anyway, we don't do the error frictions. For the student, please do the following question. This is page 101, question number 3, 4, 5, and 7. And that's it for this topic.